Okay, this is the extra credit problem for the test number 4. Compute. It's giving the inverse of the A and inverse of the B, and you need to find A and B original. There's a determinant of A is equal to 5, -7, and 6. This is multiplication here is 12. Multiplication here is negative, is plus 35, is 47. Okay, now the inverse of the inverse is the original matrix A. Entonces es you change, for example, you change the order. The order is 6, 2, and you switch, so it stays the same, but different sign is -5 and 7, and divided by the reciprocal of the determinant, que es 47. Entonces A matrix is then 6 over 47, -5 over 47, 7 over 47, and 2 over 47. This is the answer for the A. Okay, by curiosity, let's do the verification. This is A matrix, this is inverse matrix, and the multiplication must be equal to the identity, no? I suppose, I don't know. Let me see. Multiplication, this is 12, and this is 35, and this is 47. Okay, this guy is 30 minus 30 is 0. This is 14 minus 14, again is 0. And finally, this is 35 plus 12 is 47. So far we have 1 over 47 bracket 47, 0, 0, 47. So you divide this matrix by the scalar, and you get identity matrix, no? 1, 0, 0, 1. Okay, this is confirmation. Okay, now find B. First of all, determinant. Determinant of B is 7, -3, 2, and 0. Now multiplication, this is 0, and multiplication this is +6. It is 6. Now the B matrix is the inverse of the B inverse. Remember the shortcut. You interchange, you put 0 here and 7. You put here +3 and -2. And divided by the determinant value. So the inverse is 0 over 6 is 0, 3 over 6 is 1/2, this is -1/3, and this is 7 over 6. And this is the answer. Okay, again the verification. This is B, and this is B inverse. This is 1 over 6. And let's do the multiplication. This is 0, this is 6. So 0 times 7 is 0, 3 times 2 is 6. 0 times -3 is 0, and 3 times 0 is 0. This is 0 here. This is -14 and +14 is 0. And this is +6, and this is 0 is 6, +6. And when you divide this by the scalar, again we have identity matrix. Okay, now is find the multiplication A times B, this multiplication inverse. Okay, one property say that this is equivalent to the B inverse times A inverse. I suppose it's easier doing this way, knowing this way. Okay, I want to do it both ways to illustrate it's perfect. Okay, but let me prove this is true. Proof. To prove that, I suppose that AB multiplied by AB inverse. Inverse, no, inverse everything. Inverse everything. Es obvio que es equal identity matrix. Now you multiply by A inverse both sides. A inverse multiplied by AB multiplied by AB inverse is equal A inverse multiplied by identity matrix. This and this is identity matrix. The identity matrix multiplied by any matrix is the same matrix. Like Y here, inverse matrix. Now multiply by B inverse both sides. B inverse times A inverse. This again is identity matrix. Now the confirmation is this. Okay, the multiplication, the inverse of the multiplication to matrix is equal to the multiplication of the inverse but in completely different order. Okay, this is the theorem that we are using. Okay, let's do the multiplication of the B inverse times A inverse. And multiplication 7 times 2, 14. Negative 3 and negative 7, positive 21. And we combine this, the answer is 35. Multiplication 7 times 5, 35. Negative 3 times 6, negative 18. And the answer is 17. 2 times 2 is 4. 0 times negative 7 is 0. The answer is 4. And 2 times 5 is 10. Plus 0 is 10. So the answer is 35, 17, 4, and 10. This is the answer of A, B inverse. Okay, another way to get the same answer, this by curiosity, is multiply the matrix A. The matrix A is 1 over 47 multiplied by 6, negative 5, 7, 2 multiplied by the matrix B, que is 1 over 6, 0, 3, negative 2 and 7. Now let's do a multiplication of the number. Is this time this is 1 over 282. It's 47 times 6. Let's do the multiplication of the matrix. Multiplication is 0 plus 10 is 10. Okay, 6 times 0 is 0. Negative 5 and negative 2 is 10. 6 times 3 is 18. 18 minus 35 is negative 17. After that, negative 4. This is 7 times 0 is 0. 2 times 2 is negative 4. 2 times negative 2, negative 4. And finally, 7 times 3 is 21. 21 and 2 times 7 is 14. And 21 plus 14 is 35. Now let's find the inverse of this matrix. The inverse is, okay, the inverse of this matrix is the inverse of this matrix multiplied by the inverse of this number. The inverse of this number is the reciprocal, is 282. And the inverse of this matrix, remember, you switching, you put 35 here, you put 10 here, and you stay here at 17 and 4. Change the sign, opposite sign. Divided by determinant of this. And determinant of this is, let me see, 10, negative 17, negative 4, and 35. Determinant of this is multiplication, this is 350. And this is minus, 3 minus is minus 17 times 4 is 68. And when you're subtracting is 282. It's 1 over 282. And this cancels out, and this is the answer. It's exactly the same answer we obtained for the other method. Of course, the other method is much better, it's easier. But the answer is 35, 17, 4, and 10.